Everything we have seen, every planet, every orbit, every system, is controlled by one object. Not a planet, not a system, a star. A constant source of energy, gravity, and force, shaping everything in the solar system. Without it, nothing remains. No light, no heat, no life. This is the sun. The sun is not just another object. It is the center of the solar system. Over 99.8% of all mass in the solar system belongs to it. Everything else, planets, moons, asteroids, orbits because of its gravity. Without the sun, planetary motion would not exist. Earth does not move on its own. It is held, guided by the sun's gravitational field. This is not influence. It is control. The sun produces energy through nuclear fusion. At its core, hydrogen atoms combine to form helium. This process releases enormous energy. Temperatures exceed 15 million degrees Celsius. Pressure is extreme. Matter behaves differently. Fusion is continuous. Every second, the sun converts millions of tons of mass into energy. This energy moves outward, through radiation, through convection, eventually reaching the surface, and then space. The visible surface of the sun is called the photosphere. But it is not solid. It is plasma, hot ionized gas, constantly moving, boiling. Granules cover the surface, each representing convection cells. Hot plasma rises, cooler plasma sinks. This creates texture, movement. The sun is not stable. It is dynamic, always changing. The sun is active. It produces solar flares, coronal mass ejections, massive releases of energy and charged particles. These events travel through space. They reach planets. They interact with magnetic fields. On Earth, they create auroras. But stronger events can disrupt satellites, power systems, communication. The sun is not just a source of life. It is also a source of risk. At the center of the sun lies its core. This is where everything begins. Temperatures here reach over 15 million degrees Celsius. Pressure is so immense that hydrogen atoms cannot remain separate. They are forced together. Fusion occurs. 4 hydrogen nuclei combine to form helium. But the mass of the helium is slightly less than the original hydrogen. That missing mass is converted into energy. This is described by Einstein's equation, E equals mc squared. Every second, the sun converts about 600 million tons of hydrogen into helium. And in that process, roughly 4 million tons of mass becomes pure energy. This energy is what powers the sun. But it does not escape immediately. It begins a long journey outward. A journey that can take thousands, even hundreds of thousands, of years. Surrounding the core is the radiative zone. Here, energy moves outward, but not freely. Instead of flowing directly, it travels through radiation. Photons, packets of light, are constantly absorbed and re-emitted by particles. Each movement is random. A photon might travel a short distance, then change direction, then again, and again. This creates a process known as a random walk. Because of this, energy moves incredibly slowly. A photon generated in the core may take tens of thousands of years to reach the next layer. This is not a smooth flow. It is a struggle. Energy trying to escape, but constantly redirected. Beyond the radiative zone lies the convection zone. Here, the physics changes. Energy no longer moves mainly by radiation. It moves by motion. Hot plasma rises toward the surface. As it rises, it cools. Then it sinks back down. This creates massive convection currents, similar to boiling water, but on a planetary scale. Each convection cell can be thousands of kilometers wide. These movements create the visible texture on the sun's surface. Granulation. A constantly shifting pattern of rising and falling plasma. The sun is not calm. It is in constant motion. The sun is not just a ball of hot gas. It is also a magnetic system, complex and dynamic. The movement of plasma generates magnetic fields. But because the sun rotates at different speeds at different latitudes, these fields become twisted, stretched, distorted. This process is called differential rotation. Over time, magnetic field lines become tangled. They store energy, and when they suddenly realign, that energy is released. This creates solar flares and coronal mass ejections. The magnetic field is invisible, but its effects are not. It shapes the sun's activity and influences the entire solar system. The sun is not only a source of light, it is constantly emitting matter, a stream of charged particles known as the solar wind. This wind travels outward in all directions, filling the solar system. It is not gentle. It carries energy, magnetic fields, radiation. Every planet is exposed to it, but not every planet responds the same way. Earth is protected. Its magnetic field deflects most of this, guiding it around the planet. At the poles, some particles enter the atmosphere, creating auroras. But on planets without protection, the result is different. Mars lost its atmosphere, stripped away over time. The solar wind does not just pass by, it reshapes worlds. The solar wind does not stop at the planets. It continues outward, far beyond Neptune, creating a vast region known as the heliosphere, a bubble in space, defined by the sun's influence. Inside this region, solar particles dominate. Beyond it, interstellar space begins. The boundary is not fixed. It shifts, changes with solar activity. The spacecraft Voyager 1 and Voyager 2 have crossed this boundary. They now travel through interstellar space, carrying data from the edge of the sun's influence. The heliosphere is not visible, but it defines the limits of the solar system. Life on Earth depends on the sun, not just for warmth, but for energy. Photosynthesis converts sunlight into chemical energy. This process supports entire ecosystems. Without sunlight, no plants, no oxygen production, no food chains. But the sun must remain stable. Too much variation, and life would struggle. Too little energy, and Earth would freeze. The sun provides a relatively steady output over billions of years. This stability is rare. It allows life to exist, to evolve, to persist. The sun is not just important, it is essential. The sun gives life, but it can also threaten it. Solar flares and coronal mass ejections can release enormous energy. When directed toward Earth, they interact with the magnetosphere. Strong events can disrupt satellites, GPS systems, power grids. In extreme cases, global systems can be affected. Modern civilization depends on technology. Technology depends on stability. And that stability depends in part on the sun. We monitor solar activity constantly, not out of curiosity, but out of necessity. The sun is not just a distant star. It is an active force,